Here's a little example of just a little fragment really of programming in Mathematica to generate a random permutation. And what do I mean by a random permutation? Well, imagine that you have the integers 1 to 5 and you want to put them in some sort of random order, but you only want to use each one once, as if you had, put them into a box, put a bucket of 5 balls with numbers 1 through 5, and then you draw them out, blindfolded one after the other, but you're going to take them all out and you're not going to put them back, right? So you might get 3, 5, 1, 2, 4, but you won't get the 3 twice and so forth. That's what a random permutation is. So how could you generate such a thing? Well, so here's a trick to do that. That makes use of the fact that you can generate random numbers. So suppose you made yourself a table of 5 random numbers, and you do that just by generating in sequence 5 different random numbers between 0 and 1. So the first number is 0.314, and the second one's 0.728, and I'm just making these up, 0.193, and the fourth one is 0.201, and the fifth one is 0.636. Okay, so then consider these things as pairs, and the whole thing is now a list of 5 such pairs. Right? So in Mathematica, this whole list of 5 pairs is a list of 5 pairs, and each element is a pair. Now suppose that you were able to sort this list on the second element, okay, so that each one of these things you put in order depending on whether the second element is smaller or bigger. So this one would come first because 0.193 is the smallest, and so when you sort, the very first one would be 0.193, and these are all supposed to be curly brackets in Mathematica ease. And the next one would be 201. And the third one would be the 314 with the 1 tied to it. And the next one would be the 5636. And the last one would be the 2728. Well, okay, these numbers came in a random order, so which one of these came first, second, third, fourth, and fifth is therefore random. And so now if I just strip off these integers here, I will have generated a random permutation of the original. And then if I do this again and generate a new set of 5 random numbers and sort on the second one, then we'll have a new permutation. So that's a way of generating random permutations. Let's now see how one goes about doing that in Mathematica. It's surprisingly simple. So the first part is to make a table of a given length and it's a table of pairs as shown, and here we'll do 10 of them. And so here's an example, and if we execute this again, of course we'll get different random numbers every single time. And now we want to sort that table using the function sort, but we have to tell it how to sort. And so we give it a sorting function, and this is one of these on-the-fly function definitions. And the function that we give it is a function of 2 arguments, and they're called number 1 and number 2, literally number character 1 and number character 2. And the function definition that we're telling it is that it's a Boolean function, that is, it returns true or false, this kind of a function. So what it says is true if the second element of the first argument is less than the second element of the second argument. And That's our rule for putting the things in order. That is, when all of those are true, the thing's in order. That's what sort wants, a sorting function. Okay, I think you can find that out if you says sort list comma p sorts using the ordering function p. Well, that's what an ordering function looks like. So if we do that, you'll see, yes, this does sort 0.045, 0.093, 0.104, etc. Now we just want the front part of this thing. That is the 7, 2, 4, 6, 10. And the way we get that is using our ways of manipulating columns and rows. We want all of the entries, but only the first. Essentially, we want all of the rows, but only the first column. You can think of it that way because tab 2 we could write in table form. We want all of the rows, but only the first column. Right? So we can put this whole thing together into a function which looks like this. So it wants to know how many items we want, and because this is a function that has a few pieces to it in internal variables that we don't necessarily want to share with the world, we'll wrap the whole thing in a module, and we'll add the local variables into that list of local variables after we figure out what they are. So we just assemble these things that we've just written out into this single function, and so it looks like this, I, and in real. Now I goes from 1 to n, not 10, because we want to be able to have that vary. So tab is certainly going to be one of our local variables. We don't really need to have tab 2 be there. We could just sort tab 2 and make we could just sort tab using the very same thing here, which to save typing I'm just going to copy it. And then once that thing is sorted, we only want the first column of it. And so we could stop right there, and that would give us our function, which we can test here. And that works, and if we execute it again, we'll get a different random permutation and so forth. If you look, however, at what I wrote, you realize I didn't really need this internal variable tab at all. I could have just put this thing here right in there, and then I would have been done. So I could have made a simpler form of this, more compact anyway, which looks like this. Just take this business here and stick it down in there and get rid of that, and now it still works. This is a little harder to read than that, I suppose, but you read it from the inside out. You sort of ask yourself, what am I sorting? Well, this table. And how am I sorting it? Well, this way. And how much am I taking of it? Well, that much. So you read this function, which is sort of compound from the inside out. Remember that in this module here you separate multiple lines inside the module with semicolons, and the very last line, the thing that it returns, is what the module, therefore the whole function, returns. So that's just a simple example of constructing a random permutation, which gives just a little glimpse of programming techniques in Mathematica.